Okay, hi, welcome. I guess we can start. Glad you made it. It's early in the morning. I'm Marek Chmiel from Novomatic Technologies Poland, and today we're gonna do a little bit of a different thing. We're going to talk something we never talk on a day-to-day basis. We're gonna discuss security. So what I want to talk about is specifically HTTP security. But before we start, I want to know how many of you heard about Keycloak, know what Keycloak is? Okay, that's a fair amount of people. Okay, I want to share a story with you. Let's start really basic. Imagine the smallest business possible with a single web application and a bunch of users. And it's a fair assumption that at some point, those users wanted to use authenticated access to our web application. And typically what we did here, we almost immediately figured out what to do. We implemented sort of form-based authentication, and then we hooked up some database. If we were clever, then we did it in the very same database just by applying schema upgrade. And what we did is we hash passwords, then we compare and check it on the authentication. And if everything is okay, we sort of set up some kind of a HTTP session, like using cookies or whatever. Okay, that's fair enough, and that worked for quite some time. And then we've got a bunch of applications. Namely, we've got 2 right now. And we have one problem here. We want to do this as quickly as possible, and the quickest way to do it is to share the data access library, right? Because we don't have really time to extract it to some weird authentication service or so on. And what we typically did is we just reused the code from web application number 1 to web application number 2. It wasn't really pretty, but we went for it, right? Then we want to refactor some things, we want to decouple some things, and what we ended up with is some sort of a REST API or a REST-ish API. And once we did that, we figured that, well, we're going to need authentication to this REST API as well. And what we can do about it? Well, quite frankly, we did nothing about it. Because we figured, well, it's a security parameter anyway. It's a backend-to-backend communication, right? So why waste time on protecting it in any way? So we left it unprotected. And then, funny thing about APIs. People find out about APIs, and they want to use it directly. And what we were forced to do in this particular case, we were forced to implement some kind of an authentication mechanism in the REST API. So we probably going to reuse those libraries because let's say it's just roughly the same technology stack that we used in the web application number 1 and web application number 2. So we can reuse it. Obviously, it's not pretty. It's some sort of an architectural anti-pattern, but we went for it anyway. The web application 1 and the REST API, the communication between them stay unprotected. And we sort of implemented basic authentication for direct access to our REST API. And again, funny thing about basic HTTP auth is it uses the most secure, irreversible hashing functions of password called base64, right? So it's not really secure, is it? But it's fine, it works. And then there comes another child in the neighborhood, and it's called a native app or a mobile app. And the thing is, we cannot do direct database access, can we? Because we cannot access it on our low bandwidth connections, right? And we cannot do it in a mobile world anyway. So in this manner, we were sort of forced to implement the authorization service anyway. And again, what we didn't like is that the web application number one uses the REST API in an unprotected manner, and that we have currently we have a bunch of different authentication mechanisms. We're using basic auth, form-based auth, and so on and so on. We want to address it somehow. So what happened is we went for the authorization server, and it was some sort of a token service, let's say. Instead of exchanging username and passwords and passing it, because obviously we cannot put our passwords in plain text and keep it in web application and then authenticate with the REST API. So what we figured out is we can use some sort of tokens, and how it works. A user logs into the web application number one or number two. He or she enters the credentials. The credentials are exchanged in the authorization server for a token, and the token can be then reused. It roughly works the same way in web application number one, number two, native application. As for the REST API, what we can do is we actually can call authorization server directly, and we can obtain the access token and then pass it in some sort of a header. It's called authorization header. Much more the similar way how we did it in the basic auth, but instead of passing a username and password, we're passing access token. Okay, that's fair enough, but then we've got a problem, because we've got a third-party web application that wants to enter our ecosystem and wants to benefit from it. And there are three main issues with it. For one, users don't feel particularly confident when sharing their credentials with a third-party application. Because obviously, what the application is doing with my password, apart from authenticating to our authorization server. The other thing is, the authorization server does not feel particularly confident either, because, well, how do we know which clients or which applications can really I issue the access tokens for, right? Because it's a third-party application. When we have a bunch of those and we don't know them, well, it's really we're exchanging username and passwords for access token to our whole ecosystem, right? It should be somehow protected. And the other thing is, once we gain access, so we have that access token issued, and we can pretty much reuse it anywhere, right? So by having a single access token, we have an access to our whole ecosystem. And maybe there's a way to address it. Maybe we should issue access tokens directly to clients, and maybe we should identify somehow the clients. Okay, that's a fair assumption, but what we just did right here, we just basically invented OAuth 2 protocol, right? And the key principles of OAuth is, it goes like this pretty much. Apps should not store users' credentials in any form. This is what we did in the very first stage, right? Users should not share their credentials with apps, with an exception of trusted apps. This is what we did on a day-to-day basis, right? So we should avoid it. Resource servers should not be required and should not be forced to implement any sort of authentication mechanism that works on some form of passwords, right? This is, again, what we did using basic auth. Not only users, but also apps should be authorized. This is, again, the topic of a third-party application, but not only. We want to protect our ecosystem somehow. And then, obviously, access to users' resources gained by an application should be limited to the scope required by an app. That's a long sentence, but what it means is we shouldn't really reuse the access token in the our whole ecosystem. The access token should be limited to the app it is currently using. okay, fair enough. As far as OAuth protocol or framework is concerned, we've got only 4 roles. And you've already seen them. There are resource owners, which are typically, in our scenario, 95% of them are end users. I will get to that in a moment, but let's just say there are just users. There are people. We've got clients, and these are our applications, web-based, native-based, and so on and so on. We've got authorization server, which issues tokens. And we also have a bunch of resource servers. These are our APIs. RESTful, REST-ish, HTTP-based, whatever. And the first question is, well, it's fairly complex. Do we have to implement the authorization server? No, we do not. We can reuse some sort of an already existing software, because probably someone made it better, right? And what we can do is we can actually use Keycloak. Keycloak is the reference implementation of the authorization server. It is backed by Red Hat, as some of you know. I will show it to you in a minute, but first, let's talk about basic or the abstract protocol flow. And it goes like this. The client somehow detects whether user has been authorized or not. It can be checked by, I don't know, if it's a web app, it can be by a cookie, by a session storage, web storage, whatever. And then request the authorization from the user. The user authorizes the app by typically, what we typically did is we provided username and password. Then in our application, we have some sort of a authorization grant. We should exchange this proof that the user is authorized as well as the application is authorized. So now we should exchange also the identification of the application. So we're sort of, in terms of users, we've got username and passwords. Now we're going to have client ID and client secret, let's call it. And what we want to do is we want to exchange user identification, client identification, and what we're going to end up with in the stage number 4 is going to be an access token. It's going to be some sort of a string. Then we can use it and access to some sort of our REST API. That is fair enough. But what I said, that we're not supposed to share our credentials with the app. And that's true. What we should do is we actually should avoid it. But often we can't. And then when OAuth 2 grants comes in handy. And those grants typically are address different issues with different types of applications during authentication. We've got 4 of them. And there goes the authorization code, which is intended for server-side applications. We've got implicit flow. We've got which is used with mobile apps and web applications. We've got resource owner password credentials, which is used only with trusted apps, such as native apps or highly privileged apps. And we also have something called client credentials grant, which is basically how to authenticate backend-to-backend communication. But what's more important than that, we're going to focus on 2 of them. 2 of each kind, because as you see, there are 2 types of them. 2 of them are redirection-based, 2 of them are direct. Those in the blue, because they are redirection, we're not going to send username and passwords directly to the application. We're going to send it straight to the authorization server. This is only possible with the redirection flow, and as you may assume, this only going to work with the browser, right? Because this is the natural environment for the redirection flows. And the other one, the resource owner password credentials, is the direct flow when we can show the form directly in our application. It could be a web application, but we really shouldn't do it. It rather is going to be some sort of a native application. And then we're going to ask for the authorization server for the access token, and we can reuse it. So once again, resource-owned password credentials flow is what we typically did to begin with. Like, we're presenting a form, we're doing the authentication, username, and password. Instead of doing it in the app, we're exchanging it in the authorization server for an access token. And in the stage number 4, we've got an access token. Technically, it looks fairly simple. It looks like this. So we're sending a post request to the token endpoint. We're asking, we're presenting with we've got a grant type called password, because this is the user grant, and we're passing username and password in plain text. And what we ended up with typically is, apart from any other things that I don't want to mention right now, we've got an access token. It's a string, fair enough. In the implicit grant, this is the redirection-based grant. So what we do is, because we've got a web application, what we can do, we can somehow detect that the user has not been authorized before, and we're going to redirect to the authorization server. And now what the authorization server is going to do is going to present us a username and password form. We're going to fill it, and we're going to be redirected to our client app. And in the part of a URL, we're going to see some access tokens. Technically, how it goes like this. So we're sending a GET with response type to the authentication endpoint, not to the token endpoint. Authentication endpoint is meant for redirection flows. Token endpoint is meant for direct flows. Well, roughly. We asked for the response type token, which means we want to obtain an access token. And we're presenting with the client ID, which is client identification, and the redirect URI, which we're going to send access token to. And the response looks like this. So we're going to do a basic redirection with an access token in the URI fragment. OK, so at this point, let's see how this works. For those of you who want to access those examples, they are accessible through GitHub. You can do it. You can set up the whole environment just as I'm presenting it right now. So the first thing, this is Keycloak. Like this is like our authorization server. It's open source. We can log into it, and there are a lot of things happening right here. But we're not going to focus on, well, 95% of them. What we're going to focus on, the users. We can view them. And these are resource owners. These are our, let's say, registered users, right? We're going to use them to log into our applications. And we've got clients, a bunch of those, actually. Namely, we've got bunch of them, but I will present you 2 of them. One in the implicit flow, one in the resource-owned password credentials flow. It's going to be one console application written in Node.js, and it's going to be React-based application. So let's get on with it. This imitates pretty much our native client. It could be a web application, mobile application. It could be a mobile application, a native application, and so on and so on. So we're going to run this resource owner grant. And what we can do, we can log in with Jon Snow. And sure enough, we can end up with an access token. As you see, it's a string. We can reuse it to a certain extent. And this is basically how it works for the native clients. What we can do for the web-based application, this is our typical web-based application. It implements the implicit flow. What we can do is then, again, we can sign in. You see that we're not directly passing username and password to our application. Instead, we are redirected to Keycloak right away. And then we're going to use the very same credentials. fair enough, we're in our applications, we've got Jon Snow right here, and if we're going to access account, we're going to see some access token. This is fairly easy, right? Okay, let's get back. Let's just log out and get back to the presentation. And this is all nice and easy, but didn't we exchange user password for an access token, which is, well, basically another password? Well, yes, we did. And even worse, if the access token is issued for the time being of, well, when user suddenly changes its password, the access token still stays the same, right? So it's even worse than the password. Well, I think we should address it somehow. So is access token really another password? Well, for one, it's a string, right? So it must be a password. The other one is it's included in the HTTP request. So it's basically a so-called high-risk token, right? So when it's got stolen, we got access to our application, we can reuse it, and so on and so on. But what it also is, it's issued for the client that requested it. So if you can keep up the logic right here, now we kind of don't have a password, but for the one password, we've got a bunch of passwords for our applications, right? This is typically what this logic does. And the other thing is it's short-lived, rotated on a regular basis, so we cannot really do anything with it after a certain amount of time. Typically, in the best case scenarios, it's going to be 1 minute. So the access tokens in the best flows are issued, let's say, for 1 minute, and after that, even if it gets stolen, we cannot do anything with it. And the other thing, probably the most important one, is the access token can be self-contained. So it can contain some of the informations. But before we get to that, what really happens when an access token expires? Well, again, some tech. If you remember that we're having an access token in our response, we also have something called refresh token. And its sole purpose of the refresh token is to obtain another access token. That is fair enough. What we should do is we're using the post method to the token endpoint. And what we can do actually is to ask for the present with the ground type called refresh token. And we're passing the refresh token to the application. And what we can get in the response is either a new access token, and that's it, or an access token and a new refresh token. That depends on our configuration, and Keycloak also supports it. The main reason for it is because refresh token is a topic and is susceptible also to some sort of stealing the token anyway. Then this is the protection of not reusing the same refresh token for the time being of a token, right? So what we can do is we can ask Keycloak to issue the refresh token. Each time it is used, it's not going to be reused in any way. We can also reuse it 5 times and then we're done. Then we can ask for another one. And we sure can get it. And one last thing with refresh tokens. Well, it's not possible in all of the scenarios. I mentioned 4 of those. It's possible to obtain refresh token in 3 of them. So it's not possible in the implicit flow. The reason for this is implicit flow. This is the public application. It cannot keep, as you see here, we have to, in order to use refresh token, we have to identify the client somehow. So we're going to use client ID and client secret. And as you know, React apps or Angular apps or some sort of browser apps can't really, well, protect their secrets, confidentiality anyway. So it doesn't really make sense to issue refresh tokens because once it's stolen, It's going to be reused, reused, reused. Refresh tokens should be protected. So it should be server-side, right? Or it should be protected by, for example, our native app when it's hard to get, and so on and so on. Okay. Which brings us to the topic of self-contained tokens. Why are tokens so long? And this is typical token. And it has a certain format. It's called JWT, JSON Web Token. At first sight, there's nothing much going on in here. We've got just some load of letters. What if I told you that there are 3 parts of it, separated by dots, and there are, well, header, payload, and a signature? And if we're going to dig deeper, what if I told you that all of those 3 parts are base 64 encoded? And we're going to end up with something like this. The header says really how the token was signed. But the most important part is the payload. Since it's self-contained, it can contain some form of an information. Well, let's just say the expiration time. We've got the time it was issued, the issuer, the audience, so for whom the access token is really intended for. And this, some of them in the JWT specs, they are pretty much fixed. But this is an open standard, so you can use any sort of map, some sort of key value pair, and you can include it in the access token. So, for example, you can do some sort of that the user has access to, for example, view reports, right? And we also have the signature. That's a neat thing. We're going to use, since there is asymmetric cryptography, we're going to use public key, a pair of public and a private key, and we're going to sign it somehow. That's fair enough. It's a nice thing to do, but does JWT really improve anything at all? When you think about it, the authorization server is in possession of a public key and a private key. And what it does, it really signs and issues tokens signs them with the private key and issues them to the clients. And it also shares the public key with all those clients. And the client can verify that the token was issued by some server. That is fair enough, right? But how it affects really our performance, and this is pretty much the topic of a stateful, stateless session management. When we've got an access token in our client app, what we should do actually about it, we should verify it. So it means we're going to need to go through the authorization server, and we're going to want to verify it, right? And then once we got that done, we should pass it through to the some sort of our REST API, and then, well, since can be exposed really publicly to the world, we should verify it once again. So it's another round trip to the authorization server. That is not really pretty as far as the scalability of our, well, not the application, but the authorization server is concerned. So this means that we should, in our every protected call, we should call authorization server from every microservice we have. So it's not pretty. It doesn't scale really well. But instead, we've got JWT. So we sort of circuit out the authorization server from the verification process altogether. What we can do, clients and the resource servers itself can self-verify the access tokens. And this is really handy because those cryptographic methods are really quick too, and we don't have to bother about the traffic to our authorization server. Okay, so we've got key value pairs in our access token, but what are we supposed to do with it? Well, actually, those informations are really crucial to our applications. We can use it directly in our client applications, or even better, we can pass it to the resource server using the authorization bearer token. And we can benefit from the fact that those information, we don't have to access the database anymore because it's already passed in our let's say, stateless authentication mechanism and authorization mechanism. Okay, so let's see how it works. I mentioned our React app, and I also want to, this is the client app. We don't have the bit in which we're connecting with the REST API. So we're going to do it right now. We're going to set up a Spring Boot-based REST API. And this is pretty much it. This is some sort of a product service. We've got, this is also the implementation, by the way. So that's fair enough. That's pretty much how we would done it without the authorization, right? So the only thing we have to do in Keycloak in order to support authorization mechanism to our endpoints is, for one, to use those two dependencies in our Spring. It's already prepared. And the other thing is the configuration. That's it. That's all we have to do. We have to sort of fill out some basic information about who the client actually is. In our case, it's the product service. And where's the authorization server in order to verify those signatures. But the other thing is just role-based access control. So what we basically are saying here is that /API/products should be protected with users that have view products role. That's fair enough. So let's see how it works. We got our we've got our resource server up and running. So let's try to log in. Okay. Sign in as Jon Snow. And we're welcome. And what we did here, it's at the first side we did nothing, but what we did here, we used access token to disable this button. This is our first case scenario. We're using the information contained in the access token to do some stuff, well, on our front end. When we're going to see the access token, we can decode it. And we've got something like resource access, the name of the client, and then we've got roles. This is typical role-based access control, so it's pretty much a binary, what we can and what we cannot do. If it's on the list, we can do it. We obviously don't have product service view products here. So what we can do about it? Let's just sign out. We're going to Keycloak administration console. And in the client, what we have, we've got app, web, React. Oh, sorry. We've got product service. This is our API. It's bearer only. And we've got some roles defined, view products. Okay? These are the roles that we can reuse. What we can actually do is go to Jon Snow and add some role mappings to the user. So we're selecting the application called the product service. This is our API. We want to view products by Jon Snow. Let's see what we can do about it. Okay, fair enough. We can list products. We're going to access our API. How it changed in the access token? We've got product service, view products. Okay, and what we can else see in the resource server, we can use the very same mechanism to verify tokens. So it's a self-verification process, and we can read it. So everything within it, we can reuse to some extent. We can do not only role-based access control, we can use pretty much attribute-based access control. Since the access token is the key value pair, we can use any key and any value for that matter. Okay, So let's log out from here and let's go deeper. We need to go deeper. Okay, how to obtain access token in backend-to-backend scenarios. This is a typical case in which client credentials flow comes in handy. And the basic understanding of this is, let's just say we've got, well, a service registry, like Eureka, like whatever. And we've got some serious services. We want to register them in the registry. But not all of them should be able to register in our registry, because it should be protected somehow. Okay? And right now, we don't really have a notion of a user, because there is no user. We just want to, well, verify if the client can do it. And this is what the client credentials flow is all about. In client credentials flow, the client is the resource owner. This is why I said that 95% of the time it's going to be end user. Those 5% of the time it's going to be our services, our apps, and so on and so on. And it's, well, technically speaking, it's roughly the same. We're going to use the token endpoint again. We're going to present client ID and client secret, and we're going to end up with an access token. Why this is handy? Because typically what we did back in the days, we sort of need to figure out how to authenticate clients and authenticate users, well, differently. For users, we're going to use username and passwords. For clients, we sort of figure out that we're going to use some sort of an X API key header or so on and so on. And these are different authentication mechanisms. What we typically did to unify it is we tend to, well, sort of register some kind of a dummy user which reflected really the client. So OAuth protocol prevents us from doing it, and instead we can use client ID, client secret, pretty much the same where we would use username and password for the end users. Okay, which brings us to the very serious topic. How can we be sure access tokens are issued only for allowed clients? Well, when we're going to think about it, again, we've got confidential clients and we've got public clients. Confidential clients are those who are issued with client ID and client secret, and the whole purpose of client secret is to keep it secret. So it should be kept from a backend point of view, it should be kept confidential, right? Public clients, like I said, like web-based applications, like those browser-based, not the web-based, server-based things, cannot do that really, because we're going to use Chrome, we're going to press F12, and we're going to see our client secret, which doesn't really make any much sense. Okay, so as far as client identification is concerned, for our different four grant types, we've got also different requirements. And this probably our implicit flow and resource-owner password credentials flow, those presented in the first place, are not really meant to be used on production. When we've got a web application, what we should use actually is the authorization code. It has the strongest client identification mechanism, and it should be used to verify that the client is what he is meant to be. Okay? Obviously, in implicit flow, we don't have client secret, so we also don't have refresh token. And in resource owner password credential, in authorization code, we've got, well, optionally client secret. It should be there. For resource owner password credentials, sometimes it doesn't make much sense either. So if we've got a native what's the point of doing client ID, client secret in our native app? It sort of makes sense if we've got different distributions and different releases and we want to identify it somehow, but it's just a hint. So anyone who installed it can really change it, right? In the authorization code, it's well protected and it's an indication that the client application can actually use it. Okay, so this is again the implicit grant. So what we did, we sort of give username and password to the authorization server, and we ended up with an access token. There is no client identification here. The only client identification that we have here is we're verifying that the redirect URI that we're going to with the access token has been registered in our authorization server. If it's not, then we cannot do it, because obviously then we would issue access tokens wherever, right? So this is the only protection in the implicit flow, and this is what is so implicit about it. We don't know what the client actually is. So how it's different in the authorization code grant? So it starts basically the same. What we're doing is we're going to be redirected to the authorization server, and then we're going to fill up username and password, and instead of authorization server giving access token, we're going to be issued with another token. It's called code. And the code is going to be confidentially sent to the client as a proof that the user has been authorized in our authorization server. And what the client app should do now, since it's confidential, since it's web-based and a server-based one, it should reuse this code and pass client ID and client secret as well with another round trip in the stage number 4 to the authorization server, and now we're all good. Now authorization server can authorize the client as well, and we're in step number 5, we're going to end up with the very same access token that we ended up in the implicit flow. So technically it looks like this. In the implicit flow, the same endpoint, we asked for the response type called token. Now we're calling response type code, and we're going to be redirected to the auth callback with some code. This is not the access token. This is the code that the client should use as a proof that the user was authorized in the authorization server. And then what we're doing, we're sort of using basic HTTP auth to identify the client, and we're using the token endpoint, and we're sending the grant type called authorization code, passing the code, the redirect URI, and we're identifying the client using the authorization basic header. That is it. That is pretty much simple. Well, and actually that's it for today. I'm going to show you some of the cool stuff from the Keycloak perspective of view, because we've got some time left. Let's just present what Keycloak can do. Okay, so we're in the admin. We are in the realm called examples. What we actually can do, I don't like. Okay, what's the problem with delegating authorization to the authorization server? We don't always like the user experience, right? Those controls are nasty, and we don't want to use it, because if you can figure it out, it's like using best user experience should not be any implication of using resource owner password credentials grant. Because we are often attempted to use resource owner password credentials grant to, I don't like this username and password form in the Keycloak, and what I'm going to do is I'm going to implement a resource owner password credential form. No, you can customize it to a certain extent. Even you can customize it on a per client basis by sending just client ID. Okay? You should not do it, because the user is focused on passing username and password only to a single source of truth, which is going to be probably Keycloak. Okay, so to see this in action, what we can do, let's see. We can go to Realm settings. We can actually, for the login theme, use some other thing. So let's see how it works. Sign in. Fair enough. We don't have those nasty Keycloak forms anymore. We can do pretty much the same thing. Okay, the other thing. Those are really example applications, but, well, will it work in production? Do I have some example of an application that can authenticate with it? Well, sure enough, let's just find out. Kibana. Okay, let's just start it. Okay, the user has insufficient permission to access this page. Okay, this is because Kibana requires certain roles to be authorized with, right? And the user obviously doesn't have those rights. So we're going to log out, and we're going to see in the admin console what we can do about it. And here we have Kibana client, and we've got some roles code called view Kibana. So what we can do, again, we're going Jon Snow. We're going to give him access to Kibana. That's fair enough. Try to do it again. Just once again. And we're here. We're here pretty much the same as XPack would do it. Although it's free, but you can choose. Okay. And one last thing I wanted to show you. What if we did something like this? Okay, we've got some indexes with Keycloak. That's interesting. Okay, so let's discover it. Okay, and what we actually did is we sort of integrated audit logging with Elasticstack to put all those login, logout, access events to our Kibana. So we're logging to Kibana, which is basically an audit log for our authorization server. And you can see when we're going to expand it, we're going to see that in the realm examples, client ID, so the client, the user accessed from the Kibana, its username was Jon Snow, its IP address was this, and it attempted login to at this time, right? So luckily enough, we can trace all users, whether they log in from different applications, from the same application, they log out, single sign-on experiences, and so on and so on. And one last thing about it is, when you're going to think about this section, is all those information are in the access token anyway. So when we have that in access token, we can reuse it in our applications. And when we can reuse it, we can use the Elasticsearch and Kibana as our audit log base to our whole entire ecosystem. And what we can do about it is give actually the auth part of the audit log. And then in details, you can put pretty much anything. You can put like the user is currently viewing reports, or the user is currently doing something, whatever. But the whole point of doing this is we can track what user actually did in a single session in our whole bunch of applications. We can just we can do something like use this session ID. And here we are. We even got this, that the user attempts to log in and the user attempts to exchange code for an access token. We've got everything. Yeah, so, well, we're out of time, so I guess we're exactly on time. That's it for today. That's really amazing experience. If you're asking whether this is not open source, the Keycloak is open source. If you would like to use Kibana authentication, authorization, that's also open sourced by us. We're at Novomatic Technologies Poland, and we're pretty much playing with Keycloak, well, since, I don't know, 9 months or so on. So, yeah, that's it for today. Thank you.